Okay, my time is telling me that it's time to get started. Hello, everyone. My name is Alvita Otley, and I am one of the general chairs for VDS this year. I am joining from St. Louis, and I don't know where you are or what time it is, but welcome to the 10th VDS. Before we get started, I just wanted to spend a minute or two giving you an overview of what this symposium is about and where we came from, and just highlighting some of the things that you're going to see today. So VDS has always been uh, one of the goals has always been to try and bridge the gap between academia and industry. We've seen this throughout the years in terms of how we have representation on our organizing committee. We've always had people from industry and we've always had people from academia. But throughout the years, we also tried to expand VDS into different domains. So one of the key things that we tried to do was to introduce VDS to the KDD world. And this was pretty successful for 2 years. But we've transitioned a bit to being back to only Viz alone, and hopefully in the panel at the end of uh, at the end of VDS, we're gonna reflect a little bit on these decisions. So VDS started in 2015 with Daniel Keim, Hans Peter, and Claudia Silva, and we've had a whole slew of people come through. I'm just highlighting a few of the folks here who have been very instrumental in some of the major transitions for VDS. So back in about 2019, we started thinking about how might we expand VDS beyond the visualization community. And we had a team of Adam, Alex, Thorsten, and Claudia who then proposed this idea of having VDS as a part of the KDD conference. This just happened to happen around the time that COVID happened as well. So our our push to KDD was virtual for the first time and then hybrid for the second year. And that kind of affected our goal of getting people from Viz to physically go to KDD and vice versa. So we had a little bit of trouble there. But again, VDS was in person again when Viz was in Australia in 2023. And this year, because of circumstances, we're now virtual again. But we had a really good team who came together and make this happen. So thanks to John, Anna, Dylan, and Sagat, who is our web chair for saving VDS. Uh, just an overview of the schedule. We're going to start with our keynote speaker, and then there is going to be a short paper session with 3 papers. There is a break, a 30-minute break from 1:15 to 1:45, and then we're going to go into our second paper session. And then we're going to end with a panel entitled Reflections, Challenges, and Innovations, kind of just looking back at VDS over the years and looking forward. So again, our keynote speaker, he's going to be talking about uh, bringing data visualization to Tampa Bay. And just to highlight again, our panel, this is going to be made up of Claudia Silver, Hendrik, and Mark, and moderated by our very own Anna. Before we transition, I just want to give thanks to everyone who came together to put this together. So, of course, our general chairs, paper chairs, the steering committee, and our guest speakers. But then there was also a lot of work from our program committee as well to select the best papers that you will see here. Thanks also to all the authors who have contributed to the content for VDS. Finally, because this is 10 years, I want to look back at all of the people who have worked to organize it from 2015 all the way to 2024. It's been a really great experience being a part of this team, and I'm really eager to see what comes next. So without further ado, I want to introduce our keynote speaker. And one of our goals for selecting a keynote this year was to, of course, we wanted someone local. So we wanted someone from the Tampa area, but we also wanted someone who aligns with the spirit of VDS, using data science in practice. And but I was lucky enough to stumble upon Marcus, and I was really excited because the type of work that he does is really impactful. And I really would love to see more people in the visualization community partnering with people who are doing such impactful work. And I can imagine all of the things that we can get accomplished that way. So Marcus Beck is a senior scientist for the Tampa Bay Estuary Program in St. Petersburg, Florida, and he develops data analysis and visualization methods for bay health indicators. Marcus has experience with researching environmental indicators, and developing open science products to support decision-making in aquatic environments. He doesn't just do this in Florida, but the work that he does also addresses aquatic environments in the Minnesota Lake, for instance, and California streams. He also been using R statistics programming language for over 15 years. So we're really excited to see the lessons he has learned. In terms of his background, Marcus received a PhD in conservation biology with a minor in statistics from the University of Minnesota in 2013. His master's of his master's in conservation biology from the University of Minnesota in 2009, and he has a bachelor's in zoology from the University of Florida in 2007. So I'm really excited to hear what Marcus has to present to us. If you have questions, we will accept questions in Slido, and Marcus will get to address some of these questions in the end. So without further ado, I'm going to pass it over to Marcus.
So I'm trying to share my screen here. Okay. All right. Okay. Well, thank you so much, Alvita. I'm super happy to be here. I was not expecting to be invited to an event like this, but it's definitely an honor to share my experience working with the Tampa Bay Estuary Program and some of the things I'm doing along the lines of data visualization and how we're using it as a program to help us achieve our goals. When I was speaking with Alvita before this conference, I was kind of trying to get a feel for what this group is all about and what we do as an organization where there's intersections there to help learn from one another. Admittedly, I'm a self-taught data scientist, data visualization individual. I didn't never had any formal training in these tools, but it's something that I've learned over the years to be a tremendous asset for really translating the science to decision makers. So hopefully you'll get a feel for that over the next 40 minutes or so. Okay, so I was hoping this would be in person, but now we're in virtual Tampa Bay due to the circumstances that are happening there right now. As y'all know, we've been hit by 2 hurricanes recently. I'm still an evacuee at the moment, waiting to go back to St. Petersburg. So it is kind of strange to talk about Tampa Bay in a general perspective here, but keeping in mind what has happened there lately. And I'm going to close at the end with some lessons learned from some of the recent events and kind of trying to tie that into some of the general themes of what I'm going to talk about today. So this is Tampa Bay. Again, I wish everybody was here to kind of see it and experience it for all it is. But if you're not familiar with the region, this is the largest open water estuary in Florida. It's on the west coast of Florida there. I've been in the Tampa Bay area for about 5 years now. I'm a Florida native, but I've been working for the Estuary program now since 2019, so coming up on 5 years. Just a couple characteristics about Tampa Bay as a whole. Like most estuaries on the Gulf Coast, it is fairly shallow. It has a watershed area that covers about 2,200 square miles relative to the bay itself, which is about 400 square miles. And what makes this area kind of unique and sort of trying to flavor your thoughts about how we have many challenges for managing this system is that it is a a very developed watershed. There's over 3 million people that live there. And as you can imagine, when we were evacuating the area, it was just gridlock on the interstates for miles as millions of people were trying to leave the area ahead of the storm. So it is a tremendous natural resource, but it's marked by a heavily developed watershed where there's just millions of people that use the bay, depend on the bay, and sort of call it home as their location where they've settled. To give you a sense of that, so that picture I showed you in the beginning was taken from, this is downtown St. Petersburg here, was taken right here. And I wanted to show that picture in the beginning to kind of give you an idea of just what the bay looked like in a sort of semi-natural setting. And then if you turned around, you could see this sort of immense, massive buildup of just the cityscape and everyone that lives there. And so this is, like I said, St. Petersburg. This is the Tropicana Dome, which now no longer has a roof thanks to the storm. But this is Pinellas County as a whole, and I think in Florida it is the most urbanized or developed county in the state. So just to give you a sense again of just the amount of people that live in the area, the entire county is essentially built up, yet we sort of share a boundary, or we sort of coexist with this natural resource that we call Tampa Bay that we really depend on for what we do and give us a sense of place and everything we sort of think about when we live there. Sort of stepping back now, so that last picture I showed you was right about here. This is looking at basically watershed land use in the Tampa Bay watershed, and really, not to really understand all these colors here, but the red is basically all of the urbanization that has happened in the watershed to date. So you can see, I think actually by percentage wise, this is about 33% of the watershed, and all of the development kind of comes up right against the coastline. And there's a few areas that are still undeveloped, but again, I'm trying to paint a picture of this is very much an urban estuary, and you could imagine all the kind of stressors that could be impacting Tampa Bay because of this development. And then looking at that over time, this is just a simple fluvial diagram showing us what the land use was in the watershed about 34 years ago to present. This is actually our most recent land use cover layer. But you can see that essentially the developed lands have increased. There's definitely a trend that is not necessarily going to slow down anytime soon. So the first point I want to make here is that we're seeing more and more developed land use in the watershed. And the second point is this developed land is coming from areas that are either natural lands or areas that could be restored to a natural condition. And so when we think about what we do as a program, we want to conserve the natural spaces while also allowing sort of the coexistence between the natural land and what we need as humans in our urban landscape. So you see these restorable areas, they've come into developed lands in the last 30 years. Same with forests and wetlands. So this is a trend that is kind of concerning, where we're sort of losing these natural areas to development, and it's not a sustainable way to live within our watershed. So this is really the forefront of our minds in terms of what we're thinking with the major challenges for preserving and protecting Tampa Bay. So more about what we do as a program. The Tampa Bay Estuary Program is actually part of a network of NEPs, or National Estuary Programs, around the country. There's 28 of them around the country here, obviously on the coast. And these are actually funded by federal appropriations through Congress under the Clean Water Act. So we get federal dollars to support these efforts, but also local resources from our partners that kind of match those funds as well. So these are basically place-based organizations that are meant to facilitate and support the management of what we call estuaries of national significance. So our mission as a whole, so this is basically our organizational structure. We're kind of in the middle of all these different groups, but our mission as a whole is to develop and foster partnerships to implement a science-based management and restoration plan for Tampa Bay. So fairly straightforward, but science is hard to translate to action, as I'll explain in a little bit, as you all know as well. But what we are is kind of this intermediary between sort of our policy board at the top, which is elected officials or representatives from local government or state government, our management board below them, which is individuals that are actually doing kind of the boots on the ground work for managing the bay, and then various committees that we moderate that seek to vet the science that we use to help make decisions or help our management board make decisions, or engage with the community in different ways to educate and instill sort of an environmental ethic or promote volunteering efforts to work with the community on that side as well. So we are, again, this intermediary between all of these different facets. And where I think we've been most successful is we've been an NEP, an estuary program since the early 90s. And through this kind of organizational structure, the estuary program has been really put up as a success story of how the NEPs can be used to restore and protect these estuaries of national significance. So we often describe ourselves as an urban estuary in recovery. So if you look at the long-term history of water quality in Tampa Bay, this is going back to the mid-1970s to present. This is looking at chlorophyll A, so basically a measure of algae production in the bay. You could just think of it as an indicator of pollution, if you will. You see sort of that long-term decline due in part to, or a large part, due to the efforts of our partners in restoring the bay as facilitated by the estuary program. So this is a picture, a really nasty picture of what it looked like in the 70s. Chlorophyll concentrations, algae blooms sort of decline long term. And as a result, we actually saw seagrasses increase over time. So seagrasses are going to be our indicators of basically the health of Tampa Bay. They're going to indicate that the water quality is good because they're responding to basically the light environment in the water column. If there's excessive algae production, the light environment is going to be negatively affected. So by improving water quality, by reducing chlorophyll, we saw an increase in seagrass. And this is a very long-term increase. And this is, of course, going to be the product of basically reducing sources of pollution through things that we can control, like advanced wastewater treatment at our sewer treatment plants, and other stormwater control efforts, things like that. So this is, again, showing the long-term recovery. We have some challenges now. We have actually lost some of our seagrasses recently. We're still trying to wrap our heads around some of the drivers there, but by and large, Tampa Bay is still very much considered a success story. In terms of what we do as a program, we have basically three programmatic priorities. So within our organizational structure, we have three major themes that define a lot of the actions that we work with our partners to implement. So we care about clean waters and sediments, various aspects about habitats and wildlife, and of course the community aspect of engaging them, informing them, and helping them understand how to live responsibly within Tampa Bay. So just keep these in mind as I kind of describe what we do as a program and how data visualization can support these various efforts. Now, diving even deeper, I'm not expecting everybody to see all of these, but within each of these programmatic priorities, we have various actions that is basically a laundry list of all of the different components that we care about as a program for protecting and restoring Tampa Bay. So water quality, stormwater runoff, atmospheric deposition, bay habitats, freshwater inflow, public access, climate change, you name it. This is our list of items that we care about, that we try to manage and protect, and we report back to the federal level of how well we're doing in addressing these different activities. So all of that is to say that we have a lot of things on our plate, and really because we are kind of responsible for transferring the science to decision makers, we really place a very strong emphasis on science as being the core component of everything we do. Every sort of presentation or talk or product we produce is science driven. It's the foundation of all our work, and we have a science-based plan for consensus on restoring and managing Tampa Bay. Obviously, this science has got to be timely. It's got to be responsive to changes that happen, sometimes long-term, sometimes short-term, and it has to be accurate. And since I started with the program 5 years ago, open science as a more alternative perspective on how science can be done has been one of the key tools that we've leveraged to help us achieve our mission more effectively. So I'm going to talk a little bit about what open science really means to us, and also how data visualization is a really important part of that can help transfer the core science to decision making. So I have to apologize for starting at this very basic level, but when I talk about open science, I like to start with just science in general, like, because open science is still a scientific process, but to really appreciate what open science does in terms of an improvement for science, you've got to just go back to Science 101. So this is your basic scientific method. You have an observation, you develop some hypothesis or question about what's driving that observation, you collect data to support or refute that hypothesis, and then you arrive at some conclusion. And myself included, as a graduate student, you're not necessarily taught about science application or how to really bring science to decision makers. You're really just sort of taught the scientific method and all of the main conventional products that scientists have produced as a vehicle to communicate your science. And so you might often say, oh, well, I'm going to do all this great science, write this big long report, and it will answer everybody's questions and tell them how to actually implement the science. Well, we know that's not how it works in practice. There's a huge divide between conventional scientific products and management needs. How are they going to use the science in an actionable context to improve Tampa Bay, for example? And this divide exists for several different reasons. Scientists and managers don't speak the same language. Scientists aren't always the best at creating reproducible results. You might have information loss over time. If you're not, documenting what you do, the data behind the product might not be accessible to others. The workflow for producing the product might only be known to one individual. So because of all of these issues, this is why, in my opinion, it's very difficult to translate the science to management or policymakers. I often present this example as a really good demonstration of how, just one of those barriers, information loss, how this happens over time, and how conventional science has sort of failed us towards, bridging that divide or creating more open and useful products. So if you think about this from basically, this is like information content in the y-axis about a particular scientific product, and this is time on the x-axis. So if you think about you're working on a research paper, at the time that you publish that, you're going to know everything about that product. You're going to be able to, for the most part, recall the details about it in your head, because you've just been close to that content very closely over the last year or two or three since you've been working on it. As you publish it, you move on to other products or other research projects. You're not as close to that publication as you were in the past, and so you just sort of your mind goes elsewhere. You start losing detailed information about that in your immediate memory, and it just sort of declines over time. Other things like, say your laptop gets, takes a bath in the bathtub or something like that. You can lose information through just accidents. Maybe the lab burns down, whatever. That would be catastrophic, but you can lose information that way if you're not backing up or documenting what you've done. This is a big one that we care about a lot, is retirement, or just retainment of individuals, retention at different jobs. If someone leaves, they take that information base with them, unless they've been using open science tools to sort of document what they've done in a reproducible, transparent workflow. And then finally, in a worst case scenario, if somebody just when they pass away, their life's work might go to the grave with them. That is also a very unfortunate outcome that we see a lot. Just as a sort of side joke, kind of a grim joke, but we call this the bus factor. So if, for example, as a researcher in data visualization or whatever your discipline is, you're walking down the street, you get hit by a bus, Could someone pick up your work in your absence? If not, then we say that bust factor is very, very high. So when we talk about research and how it could be applied, you want to keep that bust factor very low. So if you were to somehow vanish off the face of the earth, somebody could pick up your work, your important things that you're doing with minimal effort because you're using open science tools or appropriate visualization techniques to translate that information. This is another one that I think sort of highlights the reproducibility problem. This is kind of a tongue-in-cheek example of basically lack of documentation or reproducibility. Just because people leave and they don't they take that knowledge base with them. This is from Twitter when I used to be more active on Twitter, but this is a very funny sort of hashtag that was being used to sort of demonstrate some of the practical or real world challenges that scientists often face due to just lack of documentation, reproducibility, open science methods, visualization methods. It's a real problem. Another component that I think is also really critical, data is the foundation of every scientific product, whether that's a visualization or something else. I have a very strong feeling about how data should be stored and shared. This is just one example I found of what I like to call data abuse. If you're not curating your data in a way that is transparent and others can sort of understand what that is, you are, in my opinion, said to be abusing your data. So this is, I just Googled data abuse, and this is an example that came up of just, what is going on here? I know it's not in English, but there's various colors. You don't know what they mean. There's headers in there, and this is not like a standard normalized data set that anybody could pick up and understand how it's used or how they could use it for their own purposes. And this is, not to bash Excel. I know it's a very useful and interesting product, but Excel is not data management software, and people often use it for that purpose. And because Excel tends to try to make your life easier for you, it can oftentimes inject inaccuracies in your data set if you're not careful or you're not aware of what it's doing. And so I just like to draw this to people's attention, is that how you think about data and use it is critical for everything downstream. Even further on Excel, this is an example of actually a pretty notable example of how some geneticists were using Excel to store data, and because of its sort of auto formatting features, they had to sort of hard code some of the genes to get Excel from misreading them as dates. And this is obviously not something that you want your data management software to be doing. And so this is just another example of how, if you're not careful of working with your data, you can actually create more problems than solutions. So that brings us to open science. All of these solutions, in my mind, if you're aware of them and you understand how open science can address them, you'll go a long way towards creating better, more applicable science. And so there's a lot of different definitions for open science. This was the best one I found. I'm not going to read it right here, but a couple key words is that, if you're doing open science, you should be able to collaborate more effectively, contribute to research in general or applied decision making. The products and research processes should be freely available. Their workflow should be reusable, redistributable, reproducible, etc. And just going back to that original graphic of what the scientific method is, this is from a paper that we published a couple years ago of how that general scientific workflow can be expanded and improved upon using open science methods. So this is kind of like the basic scientific workflow, but if you're using open science, you're engaging with your end users through open planning, you're documenting your data with various metadata standards, and you're making it available, you're creating results with a reproducible dynamic summary document, you're creating products that actually can be used as various decision support tools, etc. So everything that we do at the SRA program, we try to sort of envision how this workflow, how we can use it to do better science and basically more efficient means to inform decisions. So I have an example of what that looks like. This is our water quality report card. This is a great product that has been around for quite some time, but it kind of highlights one of the key challenges we've had as a program, where the creation of this report card predated me before I came onto the program, but each year it was essentially created by hand by one individual in our office using a proprietary toolkit. And again, not to bash these tools, but because these sort of the platforms being used to create this report card were kind of not open and transparent in terms of what they were doing, it was very difficult for me as an individual to come in and sort of reproduce this. So some of the problems there I talked about before relates to that. When I came on board and had to start reproducing this report card, I had to go to the individual that was responsible for creating this, understand what they did. And basically, there was a lot of effort to try to reproduce this because of the lack of open science methods that were used to produce it. So I came in and I said, okay, well, I'm going to make this better. It did take a lot of time to do this, but when all was said and done, we basically have an automated workflow for producing this report card that each year I can basically just press a button and that entire 2-page PDF is created automatically, because we've gone back and programmatically created all the workflows in a cloud-based environment so that it's reproducible and easily updated. So these are the tools we use. Like Alvita said, I'm an R programming individual, I guess. I've been using it for over 15 years. It's my language of choice. But what's great about R is that it has this entire sort of ecosystem of complementary packages, as well as other cloud-based tools that other languages can use, like GitHub, that really make it amenable to creating entire workflows from data source to product. And so this is just a short list of various things that I use for this example with a report card, but other products that we create as a program. So we create a lot of dashboards. We use a lot of document preparation systems that integrate some of the data viz products. And it's a really nice way to kind of do work. And all of this, most of the workflows are on GitHub, so that I can access from anywhere, but anybody else that has interest in reproducing what we've done can find that information as well. And at the core of all this is an R package that we wrote that, again, operationalize a lot of the processes from ingestion of the data, wrangling the data, and creating an output, whether that be a visualization or something more involved like a report card. So we spent a lot of time doing this and putting this here, but it again makes my life easier now. In a lot of cases, I can just press a button and these things can be produced, but it creates a literal archive of source code for others to use in the future or adapt for their own needs, because it's all there. It's on GitHub. It's freely available, and we think it's a really important tool for helping us do our work. So this process kind of started with, essentially mining the old tech reports from our program and understanding the processes of how the, what's the core foundational science that's used to create this report card, for example. So I had to dig into the old documents, talk to the individual that produced the report card, and basically code up everything. So, like I said, TBEP tools, Tampa Bay Estuary Program tools, made this whole process reproducible. It's online, and then that basically feeds downstream into this report card. And it's really good, going just as an example about how this really helps with reproducibility. This is just an example of how we use these kind of document preparation systems to create a seamless link between the core data and what you see either in a report card or various aspects of our website. And so when I'm creating these things, this is kind of my view of what it might look like. It's just sort of a text-based description of various annual outcomes for water quality in different parts of Tampa Bay. There's placeholders that talk about, what are, or that sort of codify the outcomes in any given year. And when this document is rendered, there's a whole bunch of functions and TBEP tools on the back end that import the data and summarize it into these different code chunks. And what an individual sees on our website is, a plain text description of various outcomes in a given year. And this might not look, super impressive, but when I have to update these things, I basically just click a button and everything is updated on the fly, and it saves me time. I don't have to do this by hand every year, and the information is as up to date as the data is available. So there's no lag between the data coming online and putting that information on our website for our partners to see. So in terms of operationalizing this, I kind of talked about coding the processes into an R package, and then that goes to a report card or whatever. I just want to show how this workflow kind of plays out, how we set it up through GitHub basically. So I said GitHub, I'm sure many of y'all are familiar with GitHub as a coding resource, but as a web page for sharing code and actually running processes either through something that you do that triggers that process, or on a schedule. You can set up jobs that produce these things automatically. So I'm creating the tools locally, I push them to GitHub, and then I set up a job that basically says, in this example, each time the partner data is updated, use the functions and TBEP tools, create the document, and if it builds successfully, it gets pushed to our website automatically. If something happens, say the structure of the raw data has changed and the functions don't work, I get an email saying that build hasn't processed correctly. So this is, not an error in the workflow in the sense that I did it wrong, but more that something has changed, I need to update it. And I only get involved in this process once it's set up when something wrong happens or an error happens. And so my time is basically only required until I get an email saying that it needs my attention. And so this is a way to sort of set up a process that gets fed to our website that essentially runs completely on its own until it requires my attention. So again, it's timely, but also it only involves me when it needs to involve me. So that's how we have a lot of our products set up to sort of save time and put them out online. And so all of this, goes back to open science in general, as well as how data visualization can support this. And so all of these processes, these workflows, the science building upon them, you could think about all of that as a cake. So we are a science-driven organization. Everything we do is driven by science. That's the bottom of the cake. These are our decades of technical resources, the source code I'm putting online, the data. If you go up the cake, this is sort of our management policy board level. They need decision support tools like dashboards, report cards, other things that can help them make informed decisions based on the strong scientific foundation. And then at the top level is the public. So these are obviously individuals that we want to instill an environmental ethic in, and we can create various communication tools to support that effort. And they're going to be at a level that's a little more generalized than the management and policy level. So there's a gradient from basically specific and foundational at the bottom, and generalizable and actionable at the top. And all of these pieces are interconnected is sort of the point of this. And of course, everybody likes cake, so that's why I use that metaphor. And this is just kind of showing you some specific examples of different parts of the cake: technical foundation, decision support tools, website integration, actionable products, etc. And then I'm going to show you a quick video of one of our dashboards. This is a different product, but this is showing you a Tidal Creek assessment dashboard that we have online. This was one of the first things that I created with several of our partners here. But this is basically data at your fingertips, where you can What it's doing here in the video is selecting a region of interest. In this case, I think it's all of Tampa Bay, but you can dynamically select that region. You can get a summary of all of the tidal creeks in that region, what their scores are. The output is filterable. You can see details about any given creek. And then at the bottom, there's this sort of aggregate summaries of all of the creeks you've selected in terms of the breakdown by score and category. And we want to make the data accessible. Most of our products have downloadable content that is hopefully documented with sufficient metadata for people to view. So let's see, I've got, I don't want to run too much over time, but I want to basically show you a few examples of challenges we've had as a program for basically translating the science to our end users, whether that be managers, policymakers, or the public. I have 4 examples. I don't think I'm going to go through them all, but I want to highlight some, just 2 actually, that I think are critically or particularly relevant to this group. So we have a Habitat Master Plan, which is a large guiding document that basically describes a couple different key things. So one, how much native land do we have in our watershed, and how is it changing? At what rate are we losing it? And then, given those rates of change, what are our appropriate targets that we should focus on for preserving those lands in terms of acreages of acreages of mangroves or wetlands, of forest, you name it. And then finally, where, once we have those targets, where can we go in the watershed to prioritize or identify areas for preservation and conservation? So this whole document lays down that information. This is a 200+ page document. As I said, that information needs to be distilled for decision makers. This is one way to think about it. There's basically just core summary tables that lay down, what is the current extent of different habitat types, where do we need to go for our short and long-term targets and goals, basically how well we're doing each year. But in order to communicate this information to our end users, we needed some way to display basically is the target currently met? For example, is the 2030 target for seagrasses met or not? And also, is the land use change trending towards or away from that target? So two pieces of information, met or not, and trending above or below that target. And we thought maybe, we could sort of color code this using different greens and yellows and reds to describe these different ways to understand the current trend and whether or not that target is met. So we came up with this report card. This is similar to our water quality report card. It uses that conventional stoplight graphic. But personally, I thought this was an interesting way to visualize the progress towards attaining these short-term goals and native habitats. But we got a lot of pushback from this because the colors are basically really hard to just wrap your head around what each one actually means. What does light green mean from dark green? How is yellow different from light green? And so we went through various iterations of this to re-envision this particular data visualization product and came up with this, which is the exact same information, but I think portrayed in a way that makes the 2 different pieces of information a lot more clear. And those 2 different pieces of information, of course, are: is the target not met, or is it met? And what is the trend? So now, instead of using colors to describe all of those different things, we're using both colors and shapes to really distinguish those 2 different pieces of information we care about. So this type of way, in terms of envisioning how we can portray different pieces of information from a large summary document, is really takes up a lot of our time as a program to really bring the science to decision makers. And if there's any way to make that process more efficient or envision how to display these things in a more clear manner, that we're constantly trying to achieve that. And so in the interest of time, I'm going to skip to the last example of our challenge as a program. And I said at the beginning about how it seems kind of strange talking about Tampa Bay now in light of what's happened in the last 2 weeks. Now we're focused on storm recovery, and we like to think about storms in the sense of the frequency and magnitude of how they've changed over time, and how we can develop resilience towards recovering or adapting to these increasing storms. And that's, of course, driven by climate change. So this is just a long-term time series of air temperature at Tampa International Airport. The trend is, obvious. We've seen an increase in temperature, and that's driving a lot of other changes in the region. And of course, one of those changes, like I said, is an increase in the frequency and magnitude of large hurricanes. And this is a graphic from a study last year, basically showing how those trends in major hurricanes have changed over time. And basically everything that's in red shows a positive increase. So more stronger and more frequent major hurricanes over the last couple of years. And these are just some examples of how hurricanes have affected Tampa Bay differently depending on where it hits along the coastline. And so to think about this, one thing that we're struggling with now is how to communicate climate change to our stakeholders, our users, the public, in a way that is understandable to them, so that they can sort of not just understand the problem, but make more informed decisions or change their behavior towards a way that's going to lessen the impact of climate change. And so we have this sort of beta dashboard product of climate change indicators, and this is just showing storms in the Tampa Bay area, or rather the Gulf of Mexico and Florida, from 1980 to present. And most of these are tropical depressions, but you can kind of see these storms are everywhere, and there's not really a clear message from this product. And so we want to move towards something that is a little more digestible, if you will. So I was thinking a lot about Hurricane Helene and Hurricane Milton, and how do we communicate why these storms are so big and why these storms are so impactful now. And I came across this interesting infographic from a couple days ago that really summarizes in one graphic why this storm, or why Milton in particular, went from a tropical storm or tropical depression to a Category 5 storm in 24 hours. And basically it's because of the heat content in the Gulf of Mexico. And this is basically, here's this year, the average heat content compared to the average from the last 10 years. And, this is a very strong data-driven graphic that is scientific in nature, but you can very quickly see, oh yeah, it doesn't take, a climate scientist to understand that the Gulf of Mexico is very hot, and that's what's likely driven the storm. And so my message to this community is that we need really succinct ways to just distill this information in a way that is, science-based, but also impactful, and hopefully translates to more informed actions and behaviors that can mitigate the effects of, climate change, because it's only going to get more and more challenging. So I've gone a little bit over time. Hope that's okay, but I really appreciate everyone's attention today, and hopefully you've learned something about our program and how we're trying to leverage data visualization and where that intersection might be with this community here. So I appreciate it.
Thank you so much, Marcus.
So should I stop sharing, or how does this work?
Yeah, you can stop sharing.
Okay. I don't know if there's any questions, but I'm happy to chat a little bit about these things.
Yeah, there are questions. I'm trying to see if I can fix the view. Okay. Right. Yeah. Okay. That was really exciting. And it's always interesting for me to see different perspectives and how you're using visualizations in your workflow, particularly coming from someone who isn't, I guess, conventionally trained in how we think about visualizations. But I really love how you pointed out some of the, I guess, call for action for the visualization community. Uh, given, in the interest of time, I'm going to just like, there are some questions online, and I'm going to share the questions with you afterward. There's also a Discord channel where you might be able to engage with the audience more and answer these questions. So I'm
Mhm.
going to select a few of them. The most popular question that I'm seeing here is, you've developed several R packages or tools over the years. Can you discuss one that you feel has been particularly impactful for environmental sciences?
Yeah, so there's I think I manage 9 on CRAN, but not all of them are immediately relevant to the work I do with the estuary program. Um, the one that is actually kind of interesting is something that came out of my dissertation. It was like a data visualization toolbox for neural network models, like really simple neural network models, like your multi-layer perceptron, not the big ones now that are terrifying. But I never anticipated that one to be really popular, and it wasn't a focus of my dissertation. But I, through the course of just using neural networks in my dissertation research, I wrote
Yeah.
some functions that I basically was like, hey, it would be interesting if somebody put this online and made it available. And lo and behold, there was a large need for basically this opening of the black box of neural network.
Ah, okay.
Because it's basically like a data in, information out, and people just sort of took the output at face value. But you want to know, like, how are the pieces related? And this package that I wrote kind of did that for these simple neural network models. And I never anticipated it to be so popular, but it's been downloaded, I think 250,000 sometimes off CRAN.
Wow. Okay.
So I'm proud of that one. Has nothing to
Of
do with the work
course.
I do now, but it's just an example of how open science and open source tools can really have a much larger impact than you ever intend them to be if you put them out online in the space that other people can use.
Yes, and we discussed this when had our very first conversation of how it would be great to see a lot of the things that we produce in the academic community make their way out into the general population. And so, like even when you talked about that, there was a chart that you had with the red and green, and then you converted it into arrows. Uh, as I was looking at that, I thought about all of the work that the academic community have done with colors and the visualization guidelines. That would have made your life so much easier if those were readily and easily available to you. So
Yeah.
you don't even need to question. Here are now some tools that might be able to give you some ideas for how to better visualize your
Yep.
data.
Yeah, the accessibility component is something that's been a challenge because like I said, I've only been with the Estuary program for 5 years. And so I'm kind of on the shoulders of giants here with all of the work that's been done before. And it's really hard to, like, for example, the red, yellow, green stoplight graphic.
Yeah.
People understand that, but it's horrible from a colorblind
Yep.
perspective.
Yep.
It's aware of that, and there's been various, hacks over the years to try to fix that. Putting the R, Y, G letters into the colors, for example. But our community of partners we work with know that product, and if we're all of a sudden be like, hey, there's new colors, you got to understand. It seems simple, but it's a product that's sort of entrenched in the management community we work with, and it's not easy to sort of take this thing that they're familiar with and make it something that is potentially foreign or unfamiliar to them.
Yeah.
But it's yeah, like I said, it involves sort of institutional change, but also
Yep.
being mindful of accessibility components, and we're actively trying to address both of those things. And any new things that we create, we're trying to be better about so that we're not, digging a deeper hole. But like you said, the tools, the data viz community can help, different ways to view concepts, whether it's colors, shapes, or other ways to think about it. We're all ears for different ways to think about that.
Okay. You know what? Let's end there.
Okay.
I It was really great, and thank you so much for giving the keynote for us. I know that for the last couple of weeks, actually, it's been tumultuous for you, and I'm really glad to see that you and your family are safe. When do you get back home? Do you know?
I'm waiting for the power to come back, and
Okay,
any day now.
okay.
But thank you
Well,
so much for the opportunity. I really appreciate it. I will. I could jump on some of the other Discord and in the Slido to see if there's any questions there.
all right, fantastic. Thank you so much again. Okay, I'm now going to hand it over to John, who is going to be uh, introducing the next session, the paper sessions.
Thanks, Alvita, and thanks, Marcus, for the fantastic keynote. So we've got three papers that are listed for this block, and we're going to start off with our selected best paper. It's a collection of 10 authors who I'm not going to read off for sake of time, but the title of the paper is Visualization and Automation in Data Science, Exploring the Paradox of Humans in the Loop, and Jen Rogers is going to be giving the presentation. So Jen, you can take it away whenever you are ready.
Thank you. Here, let me just set this up. All right. Uh, I'm hoping that this is working.
Yes, you are good to go.
Awesome. Okay. So as you already know, my name's Jen Rogers. I am presenting on behalf of my group of, there was 10 of us. And I'll be presenting our position paper, Visualization and Automation in Data Science, Exploring the Paradox of Humans in the Loop. So, sorry, gotta move this. So in 1960, sociologist Ida Ruskov-Huss published When the Computer Takes Over the Office, which captured the concern for this new technology's impact on the workforce. We've come a long way since the computers of the 1960s, but many still share those same concerns that Huss and our contemporaries felt decades ago. Instead, today, our focus is often on artificial intelligence and machine learning. So these are a sample of headlines from news articles and columns from popular media sources that I pulled from this year. A few that stood out: Elon Musk says AI will take our jobs, and AI stole my job and my work, and my boss doesn't even know somehow. And one that seems particularly existential: an opinion piece by the New York Times: if AI takes all our jobs, will it also take our purpose? So my colleagues and I, don't think you'll have to pack up your desks anytime soon. We do think we're reaching an interesting paradox with automation, specifically automation and data science. So this paradox motivated our work, where we dug into questions like what aspects of the pipeline should be automated versus what can we automate, and what should remain uniquely human. So who is we? This work came out of a DAG seminar on human-centered approaches for provenance in automated data science. We brought a unique perspective to writing a position paper like this because we represent seemingly opposing goals for automated data science. We had members of the AutoML community advancing AutoML technology and what can be automated in the data science pipeline. And we also had members of the Viz community, which fundamentally strives to visualize data to keep us humans involved in these processes. To start, we define the scope of our focus. This is the structure of the data science pipeline we use, constructed from related work and pipelines and expertise of our AutoML researchers. We structured our delineation of human and automated effort by these 8 main stages. Due to time, I'm going to keep this talk very high level. If you want to know more, especially at a stage level, please read our paper. Once we had an initial structure and reference pipeline, we sent out a survey online to the Viz and AutoML communities to figure out what the community perceptions of automation and human involvement were in the data science pipeline. So what did that look like? We had 4 Likert-style questions asking participants to rate the current level of automation and human involvement from low to high, and desired level in the future from much smaller to much larger by these 8 stages. We also had 4 open text questions asking for both shortcomings and benefits of automation and human involvement in the pipeline, with specific examples if they could provide them. We iterated on our work for over a year. Once again, due to time, I'll give a high-level overview of our main takeaways, of the strengths and challenges of automation and human involvement, which we call the good, the bad, and the human in automated data science. For one, a disadvantage of human involvement, as one respondent put it, humans slow down the process at literally every step. Automation can and does streamline aspects of the pipeline, especially in repetitive or time-consuming tasks. One respondent gave the example, if post-deployment monitoring can be automated, it would immensely reduce cost and effort from systems and projects becoming stale after publication. In addition to lower cost and effort, automating routine work decreases cognitive load for the user so that they may focus more on understanding the problem, the data, and the models. The benefits of automation are evident. I won't need to convince you of that, but I do want to persuade you in the rest of my presentation that humans have a unique value in the pipeline as well. One challenge with automation, there is no model to rule them all. As in, there's no single algorithm or optimization approach that can deliver the best results for every scenario and domain. And it's important to consider the nuances of specific data and problem domains, along with the trade-offs of different models. And these considerations often come from human insight. As well, we bring a semantic understanding and contextual relevance. Context is critical for mapping solutions to real-world tasks. Without context, as one respondent said, the found solution might not contribute to solving the actual task. And another added, automated methods cannot consider domain knowledge yet, such as importance and impact of detected features. We play a key role in defining fairness and bias. Automation is regarded as mitigating human bias and subjectivity, but paraphrasing a report from Harvard Medical School, if it's garbage in, then it's garbage out. And it's our role and responsibility to control for bias so our models don't perpetuate it. More broadly, we define fairness and the ethical dimensions of data science, such as in medical applications, where we're dealing with human lives and not just numbers. So where do we go from here? I just want to stress, this is a short position paper. It's really a starting point. We didn't solve things here. We just wanted to get you all interested so you can help solve things. There's a lot more work to be done. As well, this survey is already a year old. I would love to see what the landscape looks like now. We believe the future of data science is inherently collaborative. We believe the results of our work indicate that we as a research community or communities favor a future where automation is balanced with strategic human oversight in areas that require deep understanding and critical thinking, specifically regarding nuance, context, and subjectivity. And that's it. I'd like to thank my co-authors. I'd like to thank the Dagstuhl organizers that started all of this. I'd like to thank the VDS organizers who are making this all happen under crazy circumstances last minute, doing a great job. And thank you all for taking the time to hear about our work. So yeah, that's it.
Thanks, Jen, for the presentation, and congratulations again on the best paper. I definitely encourage everyone to go out and check out the paper. Right now, the only question on Slido is a comment saying that we've got a great session. So congratulations to your presentation for evoking that. I guess my quick question that I can give is, going back through the entire year of your research, all the way back even to the Dagstuhl with merging together these different communities. What was the most surprising result that you found? What broke your expectations the most?
Oh, that's a good question. I think, and I touched on it, but not really well enough, that we really were two groups that had seemingly opposing goals, and we ended up having the same direction, if that makes sense. So, the AutoML people, the Viz people, yeah, we started this, we were like the human group in this process, and we each had very different backgrounds and skill sets, and yeah, just having one common goal actually. So yeah, that was a nice surprise.
Fantastic. Thanks. Okay, so for sake of time, I'm going to move on to the next paper. We're a little bit behind schedule, but we can squeeze in two more papers in the next few minutes. Max Fisher is going to be giving the next presentation. The paper title is Interactive Public Transport Infrastructure Analysis Through Mobility Profiles, Making the Mobility Transition Transparent. And Max, whenever you're ready, you can take it away.
Perfect. Thank you, John. Let me just set us up. Okay, I hope you're seeing your screen now, and I can start. So thanks, John, and good afternoon, everybody. My name is Max Fischer. I'm a postdoc in the Data Analysis and Visualization Group at the University of Constance in Germany, and I'm presenting today's talk here on behalf of my co-authors, Yannick, Dennis, Dan, and Daniel. And in this talk, we will look at public transport infrastructure analysis and the transportation network in everyday life. So our society currently, as we heard this also in the keynote, and also public transport is facing several challenges. And one of the most dramatic ones is climate change and the resulting need to adapt our way of lives, and also in regard to transportation usage. And the best example here is with climate change is this. I mean, we heard about the relocation already. This was here the Trade Winds Hotel actually was flooded by Helene. Then came Milton, and now we moved online. The second part is that the energy crisis due to the war in Ukraine makes individual travel by car, for example, more expensive. So there's an incentive to move for public transport. For public transport itself, we have the problem that the network in general are legitimate networks, and they're organically grown over time, and the location of stops and routes often is not ideal. And then we have population demands for increased access and increased new forms of mobility. The problem is that existing public transportation networks struggle to actually meet these increasing demands. And I want to show you a prototypical problem from our university city, and that taking public transport actually is quite slow. For example, we have a scenario with luggage going to the train station, and when you look at Google Maps, it shows you taking the bus takes like 20 minutes. Cycling is much faster, takes 6 minutes here. That's why a lot of people cycle in our city. The car, of course, is also faster, but also directly walking is actually faster than taking the bus. So the problem is that using public transportation often is not attractive enough. And of course, you can put in much more money, and that's really a cost issue. But we wondered if we can maybe make public transportation not perfect, but how do we actually analyze the current state of public transportation? So the trains, the buses, the trams, and so on. And how can we use a data-driven approach to identify neighborhoods with maybe good transportation links, but also identify left-behind communities? And then moving on from that, how can we maybe slightly improve public transport with help of simulations of the effect of changing lines, adapting existing schedules, maybe moving bus stops or so on? And it turns out we actually can do something like that, and that's what we're presenting here today. So we developed an interactive simulation framework to this regard with connectivity at housing level detail, and we enable iterative refinements and local modifications and analyze this into case studies. And when I talk about the basic public transport quality, or the quality of a public transportation network, we refer to cumulative travel times for a typical daily routine. So we call this mobility profiles. Before I talk a bit more about that, I want to give you an overview about our whole approach, methodology, and the workflow of our framework. So it shows how we come from the data over the simulation part to the analysis result. So we start with the data, and we use public open data transport information, and there's a format called GTFS, which is very common, and many public transport providers provide data in a GTFS endpoint, basically, or there are also nationwide endpoints. And they contain a lot of information, basically all the public transportation schedules, the lines, the stops, and so on. Now, when we have the data on the network, we also need the people using it. So we use housing data, and national sources are typically have a higher quality here. And then also we need to have some information about what the people are actually doing. And there are surveys about typical behavior of people, for example, when they go to the supermarket, when they go to the doctor, when they go out for dinner, and so on. And the last missing piece is we need contextual information. That means target locations, where people go to, what they visit, which stores there are, which supermarkets there, and so on. And also open source map data. We use OpenStreetMap for that. And this information then is combined for a simulation of public transport routing, basically, and also used as different layers for enrichment in a map-like view. Now we simulate travel via the network from each individual house in a region to each point of interest. And these points of interest are sampled based on usage patterns. I will talk about these mobility profiles in a second. The idea here is basically that when we do the computation, we have travel matrices from some location to another location. And important to note is we're not reinventing the wheel here. We are using Convail's 5 routing engine here with a Python integration, basically, and then using that on top. So based on that, when we have the simulation done, we have an interactive exploration phase. So we have a map-like view where you can explore the map, show different heat maps, show different layers for context, adapt mobility profiles, or create different scenarios from that. And this in the end enables us to perform different kind of analysis modalities. For example, look at the mode of transportation. We can also look at regions or locations, how well they are served, and also do this for different population groups. So for example, is there any neighborhood which is well suited for a PhD student to live in? And all this is based on the decision with these mobility profiles. And these basically present a prototypical daily routine over the course of a day and the relative likelihood that a person follows this routine. And the defaults, how a person behaves here is based on existing service like mobility in Germany, but this can also be manually adapted or changed to different countries. And we have different agents in here. These basically means different types, prototypical types of people, for example, students or workers and so on. And we have different interests, which are grouped kind of POIs, for example, different schools, different supermarkets. And this all comes together in our system. We have different layers, as you can see here. We have for example, the ability to show different lines in there on context, show different stations, show different layers with where bicycle lanes, where bus stops, and so on, and also where's the housing information in there. And based on that, an interactive tool, you can then actually run different kind of simulations you want to do. And I brought one simulation here where we compare travel time for different typical activities based on different ages or based on groups of people. Here we have children, for example, what you see here in this neighborhood in Constance, you actually have a lot of schools and daycare facilities. So living there is quite good for children. When you look at students here in the old city of Constance, you have actually a round line basically, and that goes up to university. So if you live here, you're quite fast going to university, which is typically what students do. And also for elderly person, here a lot of doctors in these regions and supermarkets. So that's for their typical daily routine. In the beginning, I said we also want to improve the network. You want to elevate changes, and how does this editing work? So basically, you see, for example, you have some red here, meaning not well-connected neighborhoods, and you have some line, the bus line basically, and when you want to move a stop maybe to a different location and see what happens. And then this updates on the fly relatively fast, and for performance reasons, restrict this to the local neighborhood and then update in the backend basically the whole overview. We evaluated the approach with 11 participants in the user study, and what we found is that the scenario creation needs a lot of guidance. So coming up with these overview what people do and when is kind of difficult, but if you have that, it's working great. And further, we want to improve further the granularity of the points of interest selection, basically. Also, mode of transport selection is a point that might be improved further. But in general, the heat map overview and the image basically is really helpful in identifying problem areas, and the filtering and layers provide important context. In terms of limitations, we have mobility pattern, the accuracy of these mobility profiles, basically, that's the main issue, I think. Also, target timetable data is in there. There's no live delay information, basically. And limited modifications to just computing resources. When we improve that or can just add more computing power, then it becomes faster. In future work, we want to also extend it to cross-modal selection of transport. Currently, we use everything available, extend the coverage to different counties, cities, countries in general, and maybe make it interactive, publish as open science, a citizen science initiative, basically, that you can actually explore your own neighborhood. So As a takeaway, what I want you to remember is that we present an interactive framework for public transport analysis and visualizing the quality of existing infrastructure on the one hand, then detailed analysis for different demographic groups and user scenarios, and simulated the approximate effectiveness of modifications. And this is made possible by simple yet expressive visualizations, by aggregated travel time simulations with mobility profiles, and everything is based on open source real-world data. So it's easily transferable, basically, with an easily adaptable and extendable framework. And this demonstrated a data-driven approach can actually generate actual insights, reveal quality differences between different neighborhoods in a comparable and reproducible way, and visually identify inherent weak points in a city's infrastructure. Yeah, and if you want to find out more, you are happy to visit here at our website or ask a question now. Thank you.
Thanks for the presentation, Max. There's a couple of questions that came in on Slido. The top voted question, how does your system account for and visualize the varying needs of different demographic groups when analyzing public transport accessibility? So you've touched on several different groups like students, but for the accessibility feature, can you expand a little bit more on that?
Exactly. So we basically have the ability to create numerous agents. So we could create an agent that is particularly suited for a particular group of demographics. For example, people in a wheelchair or something like that, where they would need longer travel times. It depends a bit. Currently, it's not implemented if we can actually have wheelchair accessibility in there. But in principle, you can modify all the different locations and choose, for example, then only points of interest that are easily accessible, or choose lines where you know that buses or trams run that are accessible. And you can adapt this also for visitors, for example. So a lot of different demographic groups. We had just some examples in here, but it's totally customizable.
Great, thanks so much. There are definitely some more questions that are popping in on Slido, so I'll definitely remind everyone that you can interact with our presenters on Discord after their presentations. We're a little bit time limited for being able to address everyone's question, but I do appreciate the questions, and I appreciate Max's presentation again as well. So we're moving on to our last presenter for the first session. This is going to be Graziano Blasili, and he's going to be presenting towards a visual perception-based analysis of clustering quality metrics.
Okay. Hello, everyone. I'm Graziano Blasili, and I'm going to present this joint work between Sapienza University and Northeastern University. Cluster quality metrics or validity indexes are objective measure of the quality of clusterings. So they evaluate quality by assessing different properties like compactness, separation, and others. In our work, we focus on assessing the visual perception of four of them: the visibility index, the index, Kalinski-Rabat, and silhouette score. Our research is based on two research questions. The first, what is the minimal variation of a given clustering quality metric in a 2D scatter plot that a human can perceive? And the second one, can large language models emulate visual human perception by of clustering quality metrics in 2D scatter plots to simulate crowdsourcing experiments? To answer to the questions, we define a methodology used to conduct some experiments. So first, we start with a pair of scatter plots presenting the same dataset but plotted in a different way. For example, you can use different parameters for a projection algorithm. Each scatter plot has its own values for clustering metrics that can be compared between the two plots. Since the range of the metric is infinite, the values also depend on many factors like number of points, number of clusters, and so on. We use the relative percent difference to compare the variation between two values of the same metric, so between two scatter plots. And then the user is asked to compare the two plots and to determine if they look similar or different in representing the clustering. If the plot looks similar, this means that the user does not perceive the variation in the metric, and instead, if the user notices the difference, this means that the variation in the metric has been perceived. This is an example of scatter plot pairs that we use in experiment. And this approach repeated for many different values of RPD for each matrix, and with many users, allowed us to define a perception probability for the matrix. For the experiments, we created a collection of scientific datasets, almost 900 pairs with 1,000 points and clusters ranging from 2 to 5. All the dataset and the scatter plots are available for further studies on the website of the paper. And so to answer to the questions, we designed two experiments, one involving users and one involving an LLM model. The first experiment was designed to assess the human perception. We followed a two-phases approach, a data study involving two authors of the paper, which compared almost 900 pairs of the data collection, and this allowed to understand the preliminary patterns in the perception. After we did a user study, a confirmatory user study with 13 users, they expected 72 scatterplot pairs carefully selected from the original collection to confirm the preliminary patterns that emerge. These are the results. The curve represents the perception probability, that is the probability that a given difference of the metric is perceived. The dark line is the mean probability, while the area is the confidence interval. So we can see the perception probability increases when the RPD increases. That is something that we expected. The bigger is the variation, the easier is the perception. It's interesting to notice that Davis Baldwin and silhouette metrics behave similar, so the shapes are quite similar, and with an RPD of almost 40% as a threshold, after which the difference seems to be almost always noticeable. Instead, variation in the index and Kaliski paths are more difficult to perceive and show also a wider confidence interval. To assess the LLM perception, we decided to use GPT-4o, that was the last model developed by OpenAI. We replicated the data study of experiment 1, but using GPT as a user. And we tested different prompts to obtain the desired result and to better explain the task to the model. And here there is the final prompt that we used. Results are surprising, so the metrics behave similar to human perception. The Davis Baldwin and silhouette are similar, and the other two show a more difficult perception. But the overall perception is higher than human. The probability values are higher, and this means that model can perceive small differences that the human cannot. And so, as a result, there is a considerable difference in GPT perception and human perception. One limitation of this study is that we evaluate the human perception of the metric without assessing if participants made the correct choices. So, for example, in some cases, users detected difference, but they selected the worst plot in terms of clustering quality, according to a metric. And also, sometimes the four metrics did not agree always on the better plot, like in this example. The B-index and Kaliski prefer the plot on the left. Instead, Dan-index and Silhouette prefer the plot on the right. Participants of the study instead prefer plot B and also GPT. So, as a future research, we plan to investigate the correctness of the user choices in addition to the perception. We have also some limitation on the evaluation of the LLM perception. So the current state, we cannot use this model to emulate human to do crowdsourcing experiments, but it's possible that we have to use different model with some fine tuning to obtain what we need. In conclusion, a practical example of usage of the results that we obtain. So suppose I need to show dataset to the users, and I compute Disney with different parameters, and I obtain some plots. And the obtained plot can be different, like in this example. Which one is better to be presented to users, or are they similar in terms of perception? So here we have the breast cancer dataset, and look in the height difference that we can obtain only by changing the perplexity parameter of Disney, and they are quite different. So in this case, if I had to choose between plot A and D, I would choose D. And instead, if we have to choose between plot C and D, they appear similar to the user as our study confirmed. So that's all. Thank you for the attention.
Great. Thanks, Graziano. We'll give you one quick question. So I noted in your limitations the idea of switching models to see if you get different results. And the question that came up in Slido is, what do you think is driving the performance of this AI model perception?
Well, I think the model can perceive small variation in an image that human cannot see. Probably that's why the small difference was perceived with GPT.
Great, thanks so much, and thanks again to all the presenters from this session, Marcus, the keynote, and the other paper presenters. We've still got 3 more papers to go through in the second session for today, as well as panel discussion, and so definitely join us back in a few minutes as we wrap up the program for VDS.
All right. Welcome, everyone. Thank you again for joining us. We will be starting with the second paper session. Before that, quick introduction. I am Sagat Pandey. I'm a PhD student at Washington University in St. Louis, and I'm working under Dr. Alvita Otley. And without further ado, let's welcome our first paper, and that's titled The Categorical Data Map, a Multidimensional Scaling-Based Approach. And with that, Frederick, you have the stage.
Thank you for the nice introduction. I'm Frederick, and today I will present our paper, The Categorical Data Map, a Multidimensional Scaling-Based Approach. I also thank my co-authors for supporting me in this research endeavor. In the interest of time, let's go right ahead. So the visualization of categorical data is certainly not a new research topic, thinking of bar charts, pie charts, and the like. More complex visualization types are available, like parallel sets and set visualizations. Here you can see depictions of the well-known Titanic data set. We also looked at approaches like rectangular, a method to create Euler diagrams enabling the exploration of category combinations. However, these approaches do not scale very well with an increasing number of attributes and categories. For example, here the Euler diagram is split into 2 subdiagrams for a rather small number of attributes already. And here's an example of a parallel sets visualization of the mushroom data set. It exhibits a large amount of clutter through zigzagging lines, high ribbon overlap, and a large amount of thin ribbons, making the visualization hard to read. As an alternative, in our paper, we followed the idea of using dimensionality reduction to create projections of categorical data sets and to address the limitations of existing categorical data visualizations. To make this more tangible, consider the Titanic data set, which we want to project into lower dimensional space, usually 2D, preserving similarity relations. The resulting embedding is shown on the right. However, the projection depends on the dimensionality reduction method and its parameterization. In our paper, we research parameters and options for projecting categorical data using multidimensional scaling. Bruxema et al. researched multiple correspondence analysis in the past, a dimensionality reduction method for categorical data, but similar research can be done for other methods, such as TSNE, UMAP, and others. For the construction of the categorical data map, we considered the following parameters. For encoding of categorical data, we consider one-hot encoding and set-based representation. Please note that the encoding determines which distance measures can be used. For this reason, we tested Euclidean distance for one-hot encoding-based representations, and for set-based representations, we explored the overlap coefficient and the Jacquard distance. For the DR method, we compared MDS to MCA. And finally, to reduce local clutter and overplotting, we apply an overlap reduction method. In our case, we apply a force-directed method to push overplotting points apart. To enhance the readability of the resulting projection, we encode the categories of one attribute into the background using Voronoi partitioning and optionally show the categories of a data point as a glyph. Here on the very left, you can see the property sales data set without any layout enrichment, but with manual annotations. For the purchaser currently living in attribute, the layout enrichment shows a clear split of the plot, hinting at the large impact of that attribute on the projection. For the location of purchase property attribute, the layout is less clear. However, well-separated groups are still visible. And lastly, the property type purchase attribute shows the most disjointed appearance, hinting at a low influence of this attribute on the resulting embedding. We find this property interesting since the more unstructured and disjointed the layout enrichment, the harder it is to interpret. We call this fracturedness, and we consider a high fracturedness undesirable. To quantify the fracturedness, we developed two measures. First, the edge-based fracturedness simply measures the ratio of all neighboring Voronoi cells representing different categories. Here on the left, shown by V2 and V3, sorry. We also developed the component-based fracturedness, measuring the numbers of areas belonging to a category. Here on the right, S1 to S6. The benefit of edge-based fracturedness over component-based fracturedness is that it's more sensitive. However, it cannot express the impact of a single category. Here you can see the four attributes of the Titanic dataset and the associated fracturedness measure values, both increasing from left to right. We can now use these measures to drive the exploration of categorical datasets by first suggesting attributes with a low fracturedness, which are easier to interpret. We also allow for the selection and highlighting of groups of subsets. Once the user has selected data items, we show the common categories of the selection using lasso selection and highlight all items outside of the selection with the same combination of categories in the side panel on the left. A user can select attributes of the dataset listed on the side panel to change the attribute encoding in the foreground and background of the plot. But by default, attributes are sorted by their edge-based fracturedness in ascending order, and categories are ordered by their contributions to component-based fracturedness in ascending order, allowing for focus on attributes forming clear splits in the projection space. To quantify that MDS-based projections have a reasonable quality, we performed an extensive quantitative comparison to MCA. We use the following 5 measures. Trustworthiness quantifies the proportion of points that remain close in the lower dimensional representation to assess how accurately local patterns in the projection represent the data patterns. Continuity measures the ratio of points in the projection that remain close in the original space. Normalized stress quantifies how well the distances between pairs of points are preserved when mapping from the original space to the projected space. And in the interest of time, I'm going to skip over Shepard, diagram correlation, and neighborhood hit. We compared these projections for MDS using the overlap coefficient, here MDS plus O, and the Jacquard distance, MDS plus J, to MCA by applying them to 7 real-world data sets. The MDS outperforms MCA for most data sets, and quality metrics in the case of the audiology data set, however, with high category overlap, usually present in datasets with many attributes, we found that MDS combined with Jacquard distance outperforms both alternatives. We also performed an expert evaluation. Here you can see the categorical data map visualizations of the mushroom dataset using MDS with overlap coefficient. We performed here an expert study to evaluate the effectiveness of our approach. First, on the very left, you can see two poisonous mushrooms which are highlighted here. They are very similar to edible mushrooms, and so they are particularly tricky to pick here. Furthermore, comparing class and odor reveals that the poisonous outlier has a pungent odor, and continued analysis reveals that mushrooms with an unpleasant smell are poisonous. Third, after the selection of a cluster, the ring type is identified as a defining characteristic for the cohesion of visible clusters and is used as a property for the classification of mushrooms. Lastly, selecting two poisonous clusters reveals that the vast amount of poisonous mushrooms are silky at the stalk surface below ring, while there exist very few silky mushrooms that are edible. But we also found some aspects that we can improve. The Voronoi-based layout enrichment is limiting exploration. First, the color representing a category should be relative to the overall occurrence in the data. Second, the area of an individual category should be close to their projected positions. And third, the layout enrichment should visually enclose the data points with the same category. To conclude, I want to reiterate the most important findings. MDS combined with the overlap coefficient is outperforming MCA regarding common quality metrics. Our fracturedness measures effectively drive the exploration process, and in an expert study, the categorical data map revealed non-trivial findings. Thank you for your attention, and I'm ready to take questions.
Thank you, Frederick. That was a great work. More on your evaluation part where you involved experts for the tool that you created. There's a question that's asking, how could this technique be adapted for domain experts without strong data visualization experience or background?
Mm-hmm. So that's a very interesting question. I mean, you have to have basic training in the understanding of projection, specifically MDS, since that is what we focus on. I think if you focus on that, minimal additional training will be required to use this tool with any data set. That would be my opinion here.
Perfect. Thank you. There are more questions on Slido and Discord, and as they're coming up, you feel free to answer them. With that, I would like to welcome the second paper titled Interactive Counterfactual Exploration of Algorithm Harms in Recommendation System. With that, over to you, Young So.
Yeah, can you see my screen?
Yes.
Oh, yeah, okay. Yeah, so I'm Young-Soo An from University of Pittsburgh. Oh, sorry. I'm Young-Soo An from University of Pittsburgh. Today I'm happy to present our work, Interactive Counterfactual Exploration of Algorithmic Harms in Recommender Systems. Nowadays, algorithms are embedded in our daily lives, especially with the use of social media and recommendations. I also often go to several platforms in social media. But then whenever I go there, I find myself asking, why is algorithm taking me here? And why is the algorithm always getting me the similar contents or something that don't really fit my interest? If you ever felt that way, then you're not alone. Our pilot study also highlights how users perceive the impact of pretty much widely studied algorithmic effects, such as miscalibration stereotype, popularity bias, and filter bubble. All of them were found in our pilot study. But we also found that these participants largely find these remain uncertain to them. So overall, our pilot study found that users are perceiving impacts of algorithmic effects, but without knowing or controlling their impacts or what they are. But we also found that in our pilot study that users' focus is at more on topic or categorical preferences rather than individual items. And some users viewed recommender systems as a social space. They wondered where I am among a crowd of people and what other groups of people are interested in. So something like that. So based on these findings, our study aims to tackle the transparency and explainability of algorithmic effects in recommendations. Our contribution includes the development of interactive and counterfactual interface for exploring algorithmic effects in recommender system. And in the system, we presented a design of glyphs for visualizing multiple algorithmic effects together. The first part of the user space, our interface is the user space, where we projected users' preferences over 19 movie genres into two-dimensional space. So it kind of provides the holistic view of what is happening and supports social contextualization. And we think these 2D representation benefits helping kind of intuitively understand the key concepts of algorithmic effects. For example, in the 2D space, the center is the average or typical preference over the users. And when we calculate the distance from it to the specific user's recommendation, it indicates a typicality of the user's recommendation. And when we visualize a user's actual preference and recommendation together, the coordinate changes kind of indicates the miscalibration. And when we look at how the user's recommendations got closer to the center, which is typical preference, then we can see how the user's recommendation got stereotyped towards the majority preference, or it is inverse stereotype to the opposite side direction. And also the circle size, as the user circle can indicate by its reduced size, can kind of indicate the filter bubble. We also present the design of glyph to visualize combined impact of multiple effects. Here we use the metaphor of solar eclipse. So, solar eclipse kind of is kind of overlapped sun and moon. So here in this metaphor, the sun and moon represent the actual preference and the predicted preference. When it is perfectly overlapped to each other, that it indicates the perfect calibration or prediction of the recommendation. Based on this metaphor, we also incorporated the three algorithmic effects with different visual properties. So overall, more red, the glyph indicates higher algorithmic effects. And the second part of the interface is the counterfactual retrieval view. So here we want to provide the explainability on the impact of algorithmic effects. Users can kind of ask what if questions. So what if I were a different gender, or what if I preferred more genre? I have stronger preferences on this genre or less on that genre. So then we conduct the counterfactual retrieval using matching technique to kind of retrieve the actual users as the counterfactual case in the data set. So to kind of demonstrate how our system can be used, we have two usage scenario. The first scenario is data scientist understanding of overall algorithmic effects. So when the system is loaded, the user selects the stereotype here. Then the user space is so the users are colored by the stereotype. So as you can see here, users with the red circles, this means that most users are stereotyped and forced towards the center of the typical preferences. But there are some users who have opposite effect, which is called inverse stereotyping. It results in kind of a pull away effect of placing users to the periphery. Then when user is transitioning to filter bubble, then actually the kind of trend is the opposite. So users at the periphery regions tend to have higher filter bubble, which kind of reinforces their original lower diversity. When we kind of examine these two effects side by side, the same group of users were kind of inverse stereotyped, but also they got like higher filter bubble. As you can see here, these group of people have pretty much particular preferences only towards three categories. Then they got even lower diversity as an aftermath of the filter bubble. The second usage scenario is end user sense making. So users can basically see how my original preferences got changed to the recommendation. In this case, which was stereotyped towards the typical preferences. Then, if user wants to see how these can get changed, then they can specify any like preference change on like specific genres, for example, horror or romance. And then the system finds out the counterfactual cases and they can see what items they can get in this case. Yeah, so in conclusion, we present a human-centric approach to addressing the transparency and explainability of the algorithmic harms. We developed the interactive interface to help users make sense of these harms. And as a future work, we plan to evaluate our tool with various types of characteristics of users so that we can see how they perceive algorithmic harms differently and how our tools and the interfaces can be received. Yeah, that's all for the presentation, and thanks for the attention.
Thank you, Young-Soo. That was an insightful presentation on visualizing algorithmic harms in recommendation system. There are a couple of questions on Slido and Discord, and I'll just pick one of them. And it says, how could counterfactual what if scenario can be integrated into real recommender systems, and what challenges might arise?
Yeah, that's a good question. Yeah, so I think basically this what if scenario module can be embedded into like any kind of existing recommender system. But I think one challenge would be that if the counterfactual case is not kind of in a low quality, meaning that if the user asks like what if I preferred on different preferences, then the assumption is that other conditions should be controlled as the same. So in other words, the quality of the counterfactual case. So I think that kind of quality control is the most important one when it comes to how we integrate into the real recommendation systems. Yeah.
Perfect. Thank you again. With that, let's move to the last presentation, and it's called Seeing the Shift keeping an eye on semantic changes in times of LLMs. With that, let's welcome Raphael.
Yeah, hello there. I hope you can see my screen now. Great. So yeah, thank you very much. Thanks for having me, and thank you for the possibility to present my work, which is called Seeing the Shift, Keep an Eye on Semantic Changes in Times of LLMs. So basically, human language is inherently dynamic, right? So it's constantly evolving due to various factors such as cultural shifts, technological advancements, or social influences. So over time, a new word senses emerge, while existing meanings can change or also disappear. So basically, semantic change reflects the transformation of our conceptual framework of our actual language. So in closer detail, semantic change is shaped by cognitive processes, social interactions, and other contextual factors. Specifically, there are four key mechanisms of semantic change, as described by former research, especially from the field of linguistics, which are called metonymy, pejoration, subjectification, and metaphorization. Metonymy shifts meaning through associative links. For example, we call the British Prime Minister number 10, at least the English people do maybe, to call them number 10 because of the office holder, basically. Because of the address of the office holder of the Prime Minister, which is the number 10. There's pejoration and basically also its opposite, melioration, which involves changes in connotation, where words take one more negative or more positive meanings over time. For example, having the word silly shifting from an originally meaning blessed to foolish. There's metaphorization, which refers to the transfer of meaning between concepts based on perceived similarities, such as using donut, for example, to describe an inert person. And there's subjectification, which describes how meanings become more subjective over time, as in the word very, for example, which originally meant true, but now was reduced in meaning, or however works as an intensifying word. So these are all factors that are contributing for driving, or have been contributing for us and still do, for driving semantic change from a sociological perspective. Now we are living in the era of LLMs. So large language models are transforming the way we produce and interact with language, right? So these large language models are trained on data sets provided by us, by the society, but can predict and especially generate and adapt language, our language, in ways that surpass traditional methods. So basically, they are also applied in numerous domains, ranging from business communication to academic writing, you name it. So basically, these are introducing new patterns of language that are used to shape the information we process. In our work, we want to take grasps on these refinements or on these changes in the languages. So we argue that the increasing use and constant refinements of large language models are major drivers of semantic change. And these models become more integrated into our daily lives. They affect the way language is used and understood. So basically what we do is to introduce three key theories to conceptualize how large language models influence semantic change. First, the recontextualization. Second, the standardization, and third, the semantic dementia. Each theory provides a lens, basically, through which to understand how large language models alter and shape language. So to get more concrete, the first one is recontextualization. So large language models have the ability to generate language across different contexts. So they can introduce new terms or repurpose existing ones to you as a user that you did not know before. So this process of recontextualization allows language models to spread semantic concepts to novel domains. For example, you might have heard of the study from Kevin Drum or similar studies on word usages where words apparently occur quite spontaneously or quite surprisingly in, for example, more often in academic writing. In this case of Kevin Drum, it was about medical journal domains. And surprisingly, 12 was used way more often in scientific papers. So actually, since GPT was out there, so this would be a case of recontextualization. Our second theory is standardization. So we argue that LLMs through the widespread and uniform application, contribute to the homogenization of language. So by producing consistent and often unvaried outputs, this model may reduce linguistic diversity over time. So for example, Keynes et al. Showed that unique regional dialects and cultural expressions risk being diluted actually from large language models usages. So because they promote more standardized forms of language and are pushing towards some linguistic convergence. So the standardization, while useful for some applications, limit the richness of human expression. The third theory is called semantic dementia. This phenomenon refers to the gradual erosion of linguistic precision and quality as a result of biased or oversimplified language models. So when large language models rely on incomplete or erroneous training data, they can propagate misleading or inaccurate language patterns. So over time, this can lead to a degeneration in the clarity of word meanings, particularly in specialized fields like science or law, where precise terminology is critical. So we emphasize basically the needs to monitor and to mitigate these risks to preserve our linguistic nuances and also our errors or our inconsistencies in our language. So given the profound impact of large language models on our language, we believe that it's essential for the visual analytics community, to get to visual analytics part, to actively monitor these social linguistic changes. So by developing visualization tools, we can track how meanings evolve over time and ensure that language remains diverse and expressive. So our paper basically calls for interdisciplinary collaboration between computational linguists and visualization experts to address these challenges. Also, what we did in our paper is we conducted the first comprehensive review of existing methods for detecting and visualizing these semantic shifts. So we combined insights from natural language processing and visual analytics, focusing on approaches used to visualize the semantic change. I will skip over the methodology due to time aspects, but our findings were for the detection part that dynamic word embeddings are key for capturing real-time shifts in meaning. So they allow continuous updates without the need for artificial time segmentation. And also these embeddings reveal how meanings adapt and evolve in real-world contexts over time. There are also frequency-based methods that can highlight significant changes. However, they are insufficient for revealing deeper semantic dynamics. For the visualization part, there are embedding-based techniques that are the embedding-based techniques are most effective for detecting nuanced changes. So for visualizing shift in semantic relations over time in high-dimensional data, for example, and we have methods for that, for example, PCA, TSNE, or for the visualization part like scatter plots that were often used and reveal both broad trends and subtle semantic shifts. There are also context-based methods that enrich our understanding by showing how a word association changes, for example, by the use of heat maps or also simple word clouds to clarify the evolving context in which words are used. And yeah, basically, our key insight was that we need to integrate multiple models, which would be crucial and which has not been done yet enough, actually. So combining these techniques, frequency-based, embedding-based, and context-based visualizations, that will provide a comprehensive overview and a better view on our language evolution. So in conclusion, our research underscores the need for the visual analytics community, so you, to engage with the challenges posed by LLM-driven semantic change. And we contribute with the development of 3 key theories: recontextualization, standardization, and semantic dementia, which offers new conceptual lenses to understand how LLMs influence and reshape our language. While embedding-based visualizations demonstrate great potential for capturing these shifts, we need to develop more integrated interactive tools that not only track but also explain the ongoing changes. So as LLMs continue to shape our language, understanding their impact on linguistic diversity and some semantic precision is crucial as a first step. So our work highlights the necessity of interdisciplinary collaboration to preserve linguistic richness, which fully leveraging the transformative capabilities of LLMs. Thank you for listening. Thank you very much, and happy to answer your questions.
Thank you, Rafael, for this thought-provoking presentation on the impact of LLMs. There are a couple of questions on Slido.
Mhm.
And we're running short of time. So I'm just going to pick one of them. Which of the three theories on LLM impact on semantic change possess the greatest challenge for the researcher and practitioners?
That's a great question. Basically, all three are somehow interconnected because recontextualization is more like a short-term theory. Sanitization midterm and symptomatic dementia is more on a long-term run. So basically, they are all interconnected. It's hard to judge which is the most important one, but maybe the most severe one might be the semantic dementia at the end. But this is triggered based on the other two theories before. Yeah.
Well, thank you.
Thank you so much.
With that, we will now transition to our next event, hosted by Anna. Anna, over to you for the panel.
Thank you, Sagat. Hello, everyone. I am going to ask that our panelists please unmute themselves and also turn on their camera for this next portion. And while they do that, I am going to take a moment to introduce what we're doing now. Thank you everyone for making it to the end of VDS. It has been an interesting challenge to try to get like everything going during this time. So I want to thank our speakers and like the whole organizing committee for making this happen. Just while I do that, I'm going to ask technician 1 if he's okay to turn off his camera, and I'm going to ask Claudio to please share his as we go to the live stream. So we're just waiting. There we go. Thank you. So what we're going to do as part of this panel is talk about, reflections, challenges, and innovations in visualization and data science. As Alvita mentioned in the beginning, we are now at 10 years of VDS, which is a really exciting milestone. And this past decade has had a lot of really interesting contributions to the symposium. So from various guest speakers, today and over time, we've had a lot of really interesting experience and expertise talking to us about the different ways that visualization is integrated in data science workflows and vice versa. So we are just going to be taking a look at all the challenges of the past decade, new and exciting opportunities. Before we get into it, I want to take a moment to briefly introduce our panelists. So I will call you guys out. Just state your name, although I think most people know you, your role in VDS, and what you're currently up to. So Hendrik, why don't you take it away first?
Hi, Hendrik. I'm Senior Research Scientist at MIT IBM AI Lab, working on explainable AI visualization in this spiel. My relation to VDS is twofold. I had very influential, or it turns out that an influential paper was first published at VDS and then later at IEEE Viz on LSTM Viz. And I had the chance of being general chair in 2020. So this online setup is very familiar to a certain degree.
Yeah, 2020 is definitely a much more chaotic time to start a virtual conference all of a sudden. I'm going to turn it over to Mark now.
Yeah, thanks. Hi, I'm Mark. I'm a professor at Chinese Capital University in Linz, Austria. I'm also a co-founder and CSO of Data Vision. It's a spin-off company that I founded together with Alex Lex and Niels Gilmore a couple of years ago. And the company has about 25 people, visualization solutions for other R&D. And I think it's interesting to look into both worlds, the academic world and how we make progress there, and also the industry side and what customers actually pay for, which is two different things. And I was a symposium chair, I think, quite early after Claudio did it. I was doing it with Alex 2 years and then moved on to serve on the steering committee later on. I don't remember the actual year.
Thank you, Mark. If there's a way that you could just check the audio on your microphone, you're a little bit quiet, but if not, that's all right. So now, last but not least, let's turn it over to Claudio.
Hi, so I'm Claudio Silva. I'm a professor here at NYU of Computer Science and Data Science. And so I remember this, so we started the Center for Data Science here at NYU in about 10 years ago. It was Jan LeCun at the time that had the idea to start the center. And I was one of the co-founding faculty members. And about the same time, I started talking to Daniel Keim and Hans-Peter Pfister. about the need to have an event at Viz that would bring together people in these different disciplines, right? So that very early on, the idea was to have this visualization, meeting where we would be bringing in data scientists, and it would be an interdisciplinary, event. So that's kind of like how I got involved. And Hans-Peter, Daniel, and I wrote the proposal, and I think it was, yeah, the first time it happened was in 2015, and it's actually very nice to see that the event now is very similar to what we did initially. It's really amazing, and I think it's been highly successful. So
Thank you. I'll briefly introduce myself for those who don't know me. Anna, I'm one of the papers co-chairs for VDS this year. I'm also currently an assistant professor at the University of Waterloo and was formerly with Tableau Research. And I've always been very interested in viz and data science, but I'm not going to be talking very much today beyond posing the questions. And so with that, we can get started with the first one. For those that are listening in, please feel free to add your questions to the Slido. I'm taking a look at them, and I will also be relaying them to our panelists throughout the discussion. So the first sort of thing that we wanted to talk about was just looking back on the past decade. So what are some of the most significant advancements in the field of data visualization, and how have these reshaped or influenced the practice of data science? And for this particular question, I'm going to actually bring it back to Claudio first. You already gave us a good sense of the foundation and the impetus for starting the VDS Symposium. But now I'm curious, as we look back to understand sort of the impact of visualization data science, what are some of the things that stand out?
I think that when I look at the symposium, I even look back to Hendrik here. I think that we see a lot of these papers now that are really in data science, right? And it has, in a way, the symposium has really fed into Viz in a very deep way. I think a lot of the over the years, you see a lot of award-winning papers at Viz being in this area. I think that, but the impact is probably bigger. It was something that really made sure that the community was integrated with data scientists, because I think it. My impression as someone that actually I'm quite old and I've been participating in this community since I was a PhD student, and this was kind of like more than 30 years ago. And there was kind of like this notion that visualization and the sciences were a little bit separated, right? And I think that over time, now it's much more connected. And I think that this is probably one of the major, right now, I feel that members of our community can have a direct impact on science, and actually it's very widely recognized that that visualization research is an integral part of doing science.
Thank you, Claudio. Mark or Henrik, do you have any thoughts that you want to follow up on? I see Mark has unmuted, so we'll start with you first.
Yes. Is my audio better now?
It's a little bit louder, thank you.
Okay. So I agree with Claudio. I mean, the widespread use of dashboarding and visualization tools is now across all industries is quite visible, and plotting is an important part of the data science toolbox. Everyone is using it. And also, like in the last couple of years, the quality of visualizations has increased overall. So if you look at public media, how lecture results are presented, like even not at New York Times, but in local media, and so on. It has improved a lot, and also what like the average student courses, the average student produces, I would say. So I think this is a big success, and this just echoes what Claudio said. Basically, Henrik, do you have a different opinion about success?
Yeah, of course, I have to agree to a lot of what was said, but I also think there was an influence in the other way around as well. And I think one one obvious observation is I think that data science was for large part, I think, based on like open source and actually usable open source projects. And I think that's what the visualization community also started to adopt more and more. So not trying to just create an isolated thing that then is worth a paper and kind of like be done with it, but really trying to get something out there that can be used. And then this fed back to the data science community as well, because all of a sudden it was not that tricky to use a more complex thing than a bar chart. In general, I think, and this alludes to what Mark said, I think the rise of like very powerful frameworks across the whole data science pipeline, including the visualization side, is definitely something that shaped the field a lot. Yeah, like it has never been easier to create like sophisticated visualizations or data science than now. And ask me in 5 years, I probably say the same thing again, but that's definitely something like, and also the ubiquitous use of visualization. Yeah, think of weights and biases, like nobody trains an LLM without sending data to them and getting some kind of simple charts. But again, if that helps, that's the impact that you have.
Thank you. So we're seeing impact, in the Viz community in terms of like the kinds of papers we're publishing. We're seeing impact to the practitioner community in terms of like just knowledge and awareness of visualization. And then we're also seeing this cross-pollination that you mentioned, Hendrik, where we're seeing the Viz community being influenced by the practices of the data science community as well. I just want to follow up with a brief question on that to you all. Are we done as VDS? Has it been mission accomplished because we have had this impact? Or do you see a way that this community and this forum is still a place for continuing to drive innovation, at the intersection of Viz and VDS? And I want to say, being like, yeah, we're done, mission accomplished, is a legitimate answer here. Does anybody want to try tackle that one first?
Yes, we are done.
Okay, Hendrik thinks we're done.
Someone has to take the hot take at the beginning. I think I like slick structures, and to a certain degree, if you think about the mission of having an strong influence on the visualization side of things, but also influencing the data side of or the data science community, I think this conference helped, or this symposium helped to grow the people that can essentially carry that forward, and I think that's more important than potentially the venue itself. And I mean, you can always say, okay, yeah, it's still needed, and we still need to put people forward there. But I think gracefully dissolving something is also a statement of mission accomplished.
I
Go ahead,
I
Claudia.
think that so one of the I do feel that it has been highly successful and it served its purpose, but I see some things that we haven't done. So one of the ideas that we discussed originally was to do something similar to what the BioViz community has done, where one would actually have this meeting at Viz 1 year and maybe have it at more of a data science venue another year, right? And as far as I know, I haven't seen this happen. I think that this would be useful. So I kind of like see reasons maybe to maybe evolve the format and also the venues for this. Yeah, I mean, I have more to say about this, but I will stop here and then let Mark or Hendrik add to this.
Do you have any thoughts, Mark?
Yeah, sure. I mean, this idea that Claudio mentioned, that BioVis was trying to follow, that we have like appearances in both communities, that was incredibly hard to manage. I was also part of that few years. But I do think it's the right way to try. And another comment I wanted to make is, if you think about like data science, how people do it, look at those notebook style analysis or so, I think there is lots to be done, right? You doesn't feel very interactive, right? You have interactive plots, but it's hard to feed them back into the other cells. Also, tracking provenance or the workflow of doing analysis. There are many limitations in how people do data science nowadays, if you think of those as notebook style analysis.
But don't you think that could be part of this main track?
Yes, that's a whole different discussion, and I do think that satellite events shouldn't live forever, and that sometimes it's time to bring up new formats. And there's also this discussion of pre-approval.
I mean, overall, I think I agree with the sentiment of saying, like, let's reach out to the other side. Yeah, like really try to see if you can establish a workshop at NeurIPS or whatever KDD for that matter. Yeah.
Yeah. So another example of a symposium that was also highly successful. Actually, it was kind of funny. So my PhD thesis was in volume visualization, right? And it was interesting. I think it was more prestigious to have a paper at the Fall Viz Symposium than at Viz itself at the time. So I remember when I finished I knew I was going to graduate when I got my 1996 paper at Vol Viz, right? And then eventually then kind of like Viz became very prominent, and then people just started to send the paper to Viz, and then Vol Viz was kind of like retired. So I see kind of like, I think that doing this would certainly be a good option for VDS, given that there is so much data science in Viz itself. In terms of what Mark was saying, though, in that in a lot of ways, like it's still the practice of kind of like visualization for machine learning. I feel that there is still a huge gap that we can have impact in the field. So I teach a course to students in the Center for Data Science and also in computer science for in visualization for machine learning. And one of the things I noticed when I'm teaching this course in data science is that the tools we have are still not very easy for data scientists to use them, right? And also I think that our most powerful libraries are very low level, and it creates a very big burden to people in data science to adopt them and use them. And I kind of like wonder, maybe someone has a good perspective on what kind of work we need to do to remediate and answer that so that we can have even a bigger impact.
I think that actually kind of segues into, follow-on topic of conversation. Even as we look at this forum and the future of this forum, even if we admit that it's just going to be, a cross-pollination of like folks doing data science and Viz that are, integrated in the Viz community, there's still, a number of key challenges. And Claudia, you just kind of brought one up about some of the disconnects, where folks in machine learning need tooling and where we're kind of at. I'm wondering whether the rest of the panelists also see some, key and pressing challenges, at this intersection of visualization and data science, and, a way that either this forum or some other version of it or the Viz conference might support addressing those challenges. I'm going to start maybe with Mark.
Yes. I mean, I find it interesting that Claudia brought it up. I also have like lack of infrastructure on my list. Or it's not a lack, but if you like how tools developed in terms of dashboarding tools like Tableau and Power BI and what their like standing is now in other fields, like how widely they are adopted. And I think we didn't do as well in terms of libraries, right? I mean, the VJS was published in, what was that, 2011, then Megalite in 2017. And there have been a few additional papers after that, but the adoption was, I don't know, the question, what is the next D3JS, right? That is maybe easier to use and makes progress on this library side. And I don't know, or do you have the feeling that we're doing great on libraries and making them available?
So still remaining integration challenges. Hendrik, go ahead.
Good question. So, I mean, the abstraction level for libraries is definitely something interesting to look into. But on the other hand, I also see that there was a lot of influence, but not coming from our community. Yeah, like if you think about like all the libraries and notebooks, and they're adopting interaction now as well. So, and they have this very high level primitives, and they're like, okay, scatter plot, X and Y, here we go. So that's definitely kind of addressed by a community that's not ours, or is only loosely related to the visualization community. And I think that's probably also the challenge. Is like, I think quite often we still think in very academic terms, when the outside need is probably much more simple in that respect. But there is no reward structure within the academic community for putting something useful out that's simple, to say it very bluntly. So if you cannot write a paper about it, you, as a PhD student, you're not more or less like not allowed to work on it. And that's, I mean, that's a feature and a bug at the same time. Yeah, I mean, it's about intellectual merit if you think about a conference, but it's definitely about impact when you think about how to populate your ideas. And I mean, one simple thing I think we all can attest to is as soon as you have a system or an idea out there that is, yeah, like open sourced, usable, even your citation count increases. Yeah, because all of a sudden people can use it, and yeah, I mean, both of you both have experience with that.
If you, so I agree with that because if you look at like design study papers, there is this problem of overcomplication, right? You try to pack everything into, and I know all the reasons why this happens, and it's fine. But also, if you look at like those tailored solutions, and how, if I also reflect what I did as a PhD student, I worked for months on like focusing on one tailored solution for some domain-specific collaborators. That was fun, but I think the process hasn't changed a lot, right? I do see that again happening by net, for instance, that so there wasn't much improvement on creating tailored solutions. There's this like huge improvement on dashboarding and how we use that, but in terms of things that you cannot pack into a single dashboard, right? Where you need a dedicated workflow for a domain-specific problem. I don't think we are very successful on that front.
Okay.
Yeah.
Claudia,
So.
do you have any thoughts that you want to follow up on?
I don't think I have anything to add. I think Hendrik and Mark have touched on the major issues there.
I think as we, to your point, Marcus, there's still a number of challenges, reaching out to specific domains that have, more complex data, or, even perhaps reaching out to different specializations of users. This is actually like kind of even bringing up a new sort of elephant in the room, and was one of our themes at VDS about the role of AI, which may or may not enable some of that sort of personalization, and may or may not make, developing viz tools for certain domains either easier or comically bad. So I'm wondering, especially with the momentum of the past 2 years, what you're thinking about the intersection of artificial intelligence with data science, and what that means for data visualization tools that are, once again, also like kind of being developed and integrated for data science workflows. Does anybody want to tackle that question first? Go ahead, Hendrik.
So I think the underlying task did not change for the last couple of years. And this is dealing with like massive data that's, in the worst case, even complicated. But I think, I would say in the high times of visual analytics, this was addressed by mainly visual means, because the machine learning kind of algorithmic side was pretty bad, or not up to standard. And I think this side was catching up more and more now. And we have to figure out, like, what role does visualization now play? Because I mean, you see this in like funding as well. Yeah, like big sponsors of visual analytics, I don't know, Department of Energy, Department of Homeland Security. I think they are putting a lot of investment now on machine learning or AI. So the question is like, how can we redefine the role of visualization? Because it's probably not anymore the like, I want to get an overlook over my data to make some reasoning in a particular part. But as you just mentioned, these ML algorithms come up with their own kind of problems. Yeah, like, and so I think this is where I observed the shift also in the community. Like, I don't know how many ML this ML paper are at the main conference as well, but it's pretty big, I think.
You're also
Henrik,
like kind of. Go ahead, Mark. Sorry.
I just wanted to ask Henrik, like, what his opinion is on conversational AI, and I mean, now it's like a text conversation, but isn't there big potential also for this playing a big part in that, right? And because it needs reshaping of how we access the data. It's not like a fixed program, right? It's having a conversation, and that goes across all fields, but also this will play a role there. Or how do you think about that? And also others, of course. Claudia and the audience.
So
go ahead, Hendrik.
We can take a hot take there. I mean, I'm not sure that this will have a big role there. And it sounds a little bit pessimistic, but I mean, look at what kind of role interaction has in a Jupyter notebook, which is a very rudimentary form of conversation. And like, yeah, visualization is often ends to the means, but it's very rarely like integral part of within this kind of data science discovery thing in a Jupyter notebook. Going back to conversation, like changing the modality also comes with a cost. Yeah, like if you stay within a modality and you write your stuff and you get answers and you write, you kind of have like muscle memory that's working on here. But having to change the modality and interact in different ways with the same system, I'm not sure if that's a success part. I mean, as to give you ground for my skepticism is like, look at search engines, and I mean, they are still the same as 20 years ago, because most of the things that have been tried that were not like asking a question, getting a list of results in text, never kind of made it across the board, or like for a wider audience. Again, maybe very skeptical here.
Okay, I'm not sure I understand you exactly. Maybe I'm not getting exactly the point, but I don't know if this is going to be a follow-up point or something that goes on top. Is I feel that it's very obvious that visualization has been extremely important in machine learning. So, and this is actually kind of obvious, like, for instance, if you take some of the top machine learning people, so you look at, I have a colleague here at NYU, his name is Rob Fergus. I think his most cited paper is a visualization paper, or maybe one of the top two. I mean, it's literally called like visualization for CNNs. Okay, that's and then you look at someone like Jeff Hinton, also, like, you know, you take Tisney, right, is one of his most cited papers. So I think that it's very obvious to me that visualization plays an extremely important role in AI. Okay, I think maybe what Hendrik is saying is the question here is how impactful work that we call visualization is actually represented in this important work. Because and maybe this goes to what Hendrik was saying before. If you look, for instance, at the Tisney paper, it's really almost like a one-liner change on the previous paper that they had. They just changed the metric that they are doing the layouts, right? And I mean, and for them, it was a big difference because people understand what the implications are of that, right? If you try to write that as a Viz paper, as Mark pointed out, as a design study, it would be a big mess, okay? So I think that somehow the machine learning community seems to be more open at quote unquote incremental work, right? But I mean, this is actually a really bad word in the sense that the question here is not whether some work is incremental, right? Okay. It's actually whether it's how significant the work is. And somehow we need to, as a community, there's two things really that I get out of this. One is if we want to have an impact in AI, we should work, and some of us actually already do this. I know Hendrik does a lot of work that is very close, in close collaboration with the AI community. I think that more people need to do that. And then the other thing is we need to be less dogmatic about these contributions and this and that, and be more open to looking at changes in maybe there's significant work that is really like very narrow, but it can be extremely significant on how it moves forward the field.
So I think a lot of different parts of the conversation over VDS's past, where it's kind of going in the future, and even the influence of AI seems to really be about cross-pollinating, through different communities, and as a way of actually increasing impact, which can be a challenge. Being an interdisciplinary researcher or multidisciplinary researcher is really, really hard. You get into what I call the infinite background problem, where you have to explain, the value and the position of your work to different communities, and by the time you're done, the whole community has shifted. Which VDS could also be an interesting forum for bringing this kind of cross-pollinating conversations. But as we're getting into the last 10 minutes, realistically, the last 5 minutes of our conversation here, I'm wondering if you could all kind of conclude, sorry to put you on the spot, with some sort of a provocation for our community, in terms of something that, we need to do in this forum, something that we need to do beyond this forum to continue to have an impact or an influence on, visualization research, but also visualization at the intersection of data science and these emergent topics in AI. So yeah, just a short kind of provocation for our community. Anybody want to try give that a start? Go ahead, Mark.
I'm happy to. So I thought a bit about this. So if we think about the position of this in like with AI and generative AI, then I mean one thing would be to being able to generate high quality plots and dashboards like using or within a conversation, right? And the question to me is, do we need to come up with this famous theory of risk that we haven't found so far, right? I mean, we just have like points of this theory, but we have no comprehensive theory of risk, and it's also not happening next year. But the question is, do we need that in order to have something like a transformer model being able to come up with high quality visualizations? I mean, because on what grounds would the model do the suggestions, right? Because there is so much crap out there, and also more complex problems that require not a single dashboard. So I think there is tons of work out there, and yeah, my statement would be like, if we think as a community about like, do we need the theory of this and how it tends to generate it?
An interesting idea. A theory of Viz for, also supporting AI ML. How about yourselves, Hendrik or Claudio? Do one of you want to tackle the kind of provocation for our community moving forward?
So my provocation would be, it's a provocation and a suggestion, is visualization students or visualization researchers should go and attend the AI machine learning seminars and actually try to, to collaborate with people in such a way that even if what they do, they think is very simple, but if you do like something that is actually used by people, right? I mean, even I feel that and you report on it, I think that would be important. Even if it's just a blog, I don't actually care on how this gets packaged. But I actually feel that this would be kind of like interesting. As Hendrik pointed out before, this whole issue of interaction in kind of like ML visualizations that are really used is very undeveloped, right? So if people can just push this forward, it's likely to have an impact. And the only way to really do meaningful work is if you actually know what problems people are having.
Do you think that design studies kind of fill a little bit of that role of go out with the community and bring it back? Or do you think they're limited in being able to do
I'm
that?
not sure. I think that the way design studies are set up, at least now, they seem to almost like assume a very artificial interaction with people. Like no one goes like, oh, I'm gonna set all the requirements for collaborating with other people. I mean, it's just kind of like a very unnatural way to collaborate with others, right? So this idea that it's almost like the old idea of like, you throw research over the wall to other people to use. I think that we need a model in order to actually, if you really want to have impact, you need a much closer kind of like loop that happens much more immediate, right? Maybe even almost like on a daily level.
Thanks. Henrik.
Yeah, I think when you think about visualization in general, quite often when we, I don't know, when we do work with architects, etc., we automatically assume we are not the domain experts. And there's the fallacy for machine learning and this, because it's so close to computer science. Don't fall for the fallacy that you assume you are the expert in this specific machine learning field. I think that's real danger. So really try to seek the communication with people who are in this field deeply, because that really gives you an understanding of what are the actual problems, and not the potentially hypothetical problems, which also then leads to something very simple. In the best case, it's very simple that you do, and all of a sudden, there's like the whole community jumps at you and they're like, oh yeah, I didn't think about having, I don't know, like curved lines for an attention visualization, whatever. So I think that's one part. And the other part I just forgot while I was talking. So I think maybe that's then it.
We're at the end of our time. I wanted to ask just before we wrap up whether there was any last kind of like burning questions or thoughts, and maybe Hendrik, you'll remember your second point as well, that any of our panelists wanted to bring up before we close out our panel. Hendrik, you got it. Go ahead.
Epiphany. No, especially if you're in the opposite role as a reviewer, really try to evaluate if even simple stuff is useful. So if it's stated that 10 oncologists really liked what you did, that's a strong statement. Yeah, even if it's just a slightly modified bar chart.
Thank you. Mark or Claudio, any last burning, sort of statements that you wanted to make for our community before we wrap up?
It's been fun being here and to see the perspective of everyone. And thank you for moderating the questions and for inviting us. And Mark and Hendrik for teaching me a whole bunch of things that I didn't know.
Okay. So once again, I want to thank Claudio, Mark, and Hendrik for being our panelists today. Thank you so much for sharing your insights, and for the folks, like it's very hard to get a sense of like who's online and watching, but if it's just the four of us, I enjoyed our conversation. It was very delightful, and I also learned a lot. And thank you also for your thoughts on VDS over the years, the impact that it had on the community. I think there's a consistent message here that there is still work to be done, but that there has also been a really good impact that's been a cross-pollination, with the main Viz conference, and we need to see that continue to work and extend to other communities. And that this might be one of our key challenges as VDS or as visualization researchers, kind of focusing on this intersection of data science and emerging areas of artificial intelligence. I'm going to now share my screen and bring up the last few slides before we get officially cut off by the broadcast here. Okay. Oh, wow. Okay, I can't. I was the one person who did not test their video before joining us, so I can't actually share the slides without leaving. Okay, so with just that, I'm going to thank everybody for participating once again in VDS today. I want to thank our organizing committee, general chairs John and Alvita. I want to thank my co-chair Dylan. I also want to thank Saugat, who was our web chair. I want to take a moment as well to acknowledge our various speakers. It has been a really challenging week. I want to thank our keynote speaker, Marcus Beck, who was personally affected by both of the hurricanes in the Tampa area, had to evacuate with his family and was gave his keynote still evacuated. And so we're grateful to have him there for his thoughts and his perspective on visualization, with the estuary management in Tampa Bay. I also want to thank all of our speakers who, there was a lot of coordination at the last minute in the back end as we went to this virtual format. Thank you so much for everybody for showing up on time, having your slides ready, and making this go as smoothly as it possibly could. Thank you to everybody who participated today in the audience and who shared their thoughts and their questions. And last but not least, it has been 10 years of VDS. Will there be 10 years more? We will see. Please feel free to get in touch with us and to get involved. And once again, thank you, everybody. And we hope that you enjoy the rest of Viz and the rest of your afternoon.